So these complex numbers, and you've just had a go at converting from one to the other using a calculator. Can be used to represent vectors, and that's their real power. They can be used to represent vectors. Two-dimensional objects, we let the real part represent the x coordinate and the imaginary part, or the, if you'd like, the angle, represent the imaginary part of it. Actually, that's not quite true for that. That's why we got to think of this is splitting it exactly into the real part and the imaginary part. Here, it's combined into one number. And so we have to then separate it out to get the real part and the imaginary part. So if I want to know what the real and imaginary parts are, I need it in rectangular or Cartesian form. So we can convert from one to the other. And because we use them to represent vectors, now if we can learn how to add, subtract, multiply and divide complex numbers, and how to square complex numbers, how to find the square roots of complex numbers, and all these other things we can do with them, then we can manipulate algebraically vectors. And so it's a useful skill to be able to manipulate complex numbers, and we're going to quickly go through how that works. First of all, adding and subtracting complex numbers. What we do is, it's quite straightforward, we add and subtract the real and imaginary parts separately. So that means that we must have the real and the imaginary parts separately. So if our complex number is in polar form, we have to convert back to rectangular form, and then we can add them. We cannot add and subtract in polar form. So you get your calculator out, convert your numbers to Cartesian or rectangular form, and then you can add them. I add the real parts separately. 5 plus 6 is 11. And I add the imaginary parts separately. 3j plus minus 2, so 3 minus 2 is 1. I wouldn't put the 1 like in algebra. We don't put 1x, we just put x. In the same way, we just put j, so that means 1j. Complex number, so I put a bracket around it. There's my real part and my imaginary part. What about that one? Write down what you think the answer to that one will be. So this time I'm subtracting one complex number from another. 3 plus 2j minus 4 minus 6j. Subtract the real parts. 3 minus 4 minus 1. Just beware of signs. The next one, 2j minus minus plus 2j plus 6j, 8j. So that would be those two numbers subtracted from each other. So we can now add and subtract real and imaginary, complex numbers. If I wanted to add those, what would I have to do? Convert. So convert those to rectangular form, add them, and then convert the answer back to polar again. Okay, so there's the answer, 15 angle 32, or modulus 15 argument 32 degrees in polar form.